Amplitronic. Listen to the difference.
Hi, I'm Chris from Amplitronic, and today I'm going to demonstrate the latest Loopworks Design update for you. We've recently launched a new edit mode which allows you to take any automated design and manually add, remove and adjust points to fit more complex rooms. As you can see here, I've got a small teaching space with a wall that cuts in around halfway down one side. There's also a couple of pillars to be aware of, so the automated design doesn't quite fit the bill. Looking at the inputs page, you can see that I've got this set up for a fairly straightforward low spill system. I've put dimensions in to suit the largest aspects of the room, set my loop height to be at floor level, and my listening height to be at seated listening level. I've assigned gaps around the room to get it closest to the design that I'm looking for. I've chosen my floor construction to make sure that I'm allowing for a sufficient amount of metal loss. And I've selected suitable cable types for the installation. This has obviously created me a nice design as usual. But when I've got a non-rectangular space, I need to do a little bit more work in order to make this ready to install. If you'd like to use this feature, but you can't see the loop layout tab, or when you click on the edit coordinates button, you get a different message, just contact your local Amplitronic representative to discuss your user level. This dialog here warns me that changes may impact on performance within the room, as well as overspill to other areas. So make sure to avoid significant changes to the main loop segment widths and to review the variation and overspill tabs after any edits to confirm the performance of the loop is still suitable for your application. I'm going to click OK to confirm the dialog and proceed with changes to the design. Immediately you can see that our dimensions table has been converted into a list of every individual coordinate. As I hover over the various rows, I've got an X button that gives me the option to remove a coordinate and a plus button that gives me the option to add a new coordinate in the row below. It's also added point markers to each corner of the wiring layout to make it more obvious where my coordinates are. And as I click into some of these text cells, it highlights the point that I'm working on to make it more obvious. I'm going to get started and add the diversion around this area of wall at the top right here. I'll start with the red array, which is array 2. And to make it a bit easier to see, for the time being, I'm going to untick the array 1 box here, which hides that layer on the drawing. The first thing I want to do is start moving these top points down. You might notice that the points move around in a slightly unusual order. You can see the arrows and the points follow the direction of the current flow. Due to these crossovers, which are critical to the functioning of a hearing loop system, we sometimes skip past a loop segment and go to the next one. The easiest thing, therefore, is to have a look at the grid and find the rough dimensions that you're looking for, and then identify that point in the table below. So we're looking for just over 10 meters on the x-axis. We can see that point here. All I want to do is bring that point down on the y-axis to just above this 5 meter line. I'm going to go for 5.1. As soon as I press the enter key, that point updates on the drawing and I can see the new position. I'm going to do the same thing with the previous points. Looking at the arrow on the wire, you can easily see which point is before and which one is after. So that end loop is now adjusted as I want. The next wire I've got to move down is this one here. I'm looking for around 8.9, which is this point. I'm going to move this one down to just below the previous wire because I need to keep some offset between them for clarity. So I'm going to move that to 5. And again, I'm going to move the next point as well. You can see here that's opened up quite a big gap in this loop segment. That might be okay, but it's changing the design and we'll probably get quite a bit of extra spill from that. what I'm going to do then is I'm going to find this point here, and I'm going to add a new point so that I can start bringing the wire down and across. So I simply want to click the plus button here. That will add a new coordinate below. We put focus on the new coordinate so it's highlighted by default, and we insert that at the exact halfway point between the existing and the next coordinate. I'm going to move that along to match this position, which we can see is the 5.488 here. So I'm going to type 5.488 in this box. Okay, that's where I want it, and I'm going to add another point underneath. So I want that to be in exactly the same position on the x-axis, 5.488, but I'm going to drop that down on the y-axis, and I'm going to line it up with these ones which were at 5.1. The last thing I need to do then is just move this final point down to 5.1 as well. And you can see I've now made some nice adjustments to neatly avoid this wall. I'm going to turn the green array back on, and I'm going to make the same sort of adjustments here. Because the green array has the crossovers on the other side, it's a bit easier to adjust this one. I'm going to leave the red array on as well so you can see how these fit in alongside each other. So first off, I'm going to find this last segment, which is the 11 meters on the x-axis, and I'm going to bring this down to 5.05. Remember, we set on the red array, we used 5 meters and 5.1. So using this 5.05, this is going to slot in nicely between those two wires on the red array. The next one I'm looking for is around 7.5, so that's this one. And again, I'm going to move both of these y-axis points here and here to 5.05, and you can see that's slotted in nicely. I've now got to add a couple more points again to avoid the corner here. So I want to start on this point, which is around 4.5 meters. It's this one here. I'll add a new point in there, and that's coming at a pretty good place. I could adjust it if I wanted, but I'm pretty happy with that, so I'm going to leave that there. I'm going to add another point in, and I'm going to match that x-axis position of 5.75, but I'm going to drop it down on the y-axis to the 5.05 point that we've been using. And then the last thing I've got to do is just adjust this one as well. So there we go. I've dealt with that first obstruction. The next thing I'm going to deal with quickly is this pillar down here. So again, that's this 4.6 approximate wire. I could decide that I'm going to add more points and I'm going to start adding diversions and moving around and playing about, but I don't want to do that. If I've made a point that I don't want anymore, or I want to remove an existing part of the loop design, I can just click the remove coordinate button. It'll give me a warning and then get rid of that row in the table for me. Because this is a fairly small adjustment, just to give myself the same sort of spacing on the left-hand side of the pillar as I've got underneath, I'm just going to move the entire wire. So move both x-axis dimensions there to 4.5. And there we go. Finally, on the top left here, I'm hitting another obstruction, this pillar in the corner. Now, I could move this entire wire in, or I could have added a bigger gap when I was setting up the original automated design. I would always recommend getting the automated design as close as possible to what you want as you can. But I want to allow coverage of the teaching area here. It's possible that the teacher might be a hearing aid user as well, and they may benefit from making use of the loop too. So I'm going to add another small diversion in this corner. So again, I'm going to add a new point here. I don't need to move that position. Again, I can use the y-axis and the grid to help me find the right place. So I might want to put that around 5.6, for instance. If you put it somewhere and you want to move it, you can easily do so. Just adjust the value again. I'm going to add another point here, and I'm going to keep that the same position on the y-axis, but I'm going to move it along a little bit on the x-axis, and then finally I'm going to move this point here to the same position on the x-axis to square that off. Okay, and I'm pretty happy with that. I've accounted for 3 obstructions, made a pretty significant change to my loop design, all in a matter of a few minutes. If I make any changes I don't want, I can hit cancel, and that will discard everything I've done. I'm going to hit save instead, and just wait a couple of moments while it recalculates the design based on those changes that you've made. There we go, that's now done. So you can see it's got rid of those points because I'm now no longer in edit mode. And I can go back to my outputs tab, and you can see that that's obviously had an impact on our coverage. So if I click through to variation, we can see that where we've come in the top right here, we've obviously dropped a little bit of signal. On the overspill tab, again, I can see that there's a bit of an impact here because where I've dropped down, the cancellation loops aren't really doing what they were doing before. In some cases, you might want to go back and make some amendments to try and optimize that. But here we're not too fussed, and that's minus 34 dB, which is below the level required by the 60118-4 standards for background noise. As normal, I can go into my equipment tab, review the cable lengths and power requirements. It's recommended me an amplifier, which I could change if I want, or from the amplifier it's recommended, I can adjust and choose to upgrade to a Dante enabled version, for example. If you go back to the inputs tab, you can see that it's now entered this into the edited system type, which wasn't previously available. And most of the input options have become read-only because they're now based on your edited coordinates instead of these parameters. Because we've made edits, it also can't calculate the loss for us based on its kind of automated segment width, but it's converted its previous loss allowance into a manual figure there. If need be, you can amend that if you want. On the outputs tabs, we can also adjust the manual adjustment level if we want to turn this up or down, but that's been preset at a level that will match the automated design you started from. Finally, you have the options to issue your design, which will make it read-only. You can request support, which will put a ticket through to the animatronic design engineers to help you. And once it's issued, you can also request approval, which will allow us to put our stamp of approval on it for you. You can export a report, which will give you a full PDF to download with all of the coverage plots, loop layout, amplifier, hardware, etc. And lastly, we can export it as a DXF design, which means you can drop it straight into your CAD floor plan, and you can then dimension that up however you want, which can be especially useful when you've got more complex designs with non-standard shapes. For the most complex requirements, Animatronic's team of expert design engineers will always be on hand to produce installation drawings for you. However, with this update, you now have the power to make simple changes right within the Loopworks Design tool. If you don't have an account already, you can register for free at loopworks.animatronic.com. Make sure to head to the Learn and Training Courses section to go through our on-demand design training course before you get started. Thank you for watching.
Animatronic. Listen to the difference.